we know something about motion. Chapter 8 of class 9 CBSE. Motion of a body is defined as the change in position with time with respect to some stationary body. That is, if a body moves so that its position changes with time with respect to some stationary body, then it is called motion. Right? Okay. We know some terms about motion. We know some terms about motion, for example, speed. The speed of a moving body. The speed of a moving body is defined as the change of path of a body, change of path of it with time. Moving body is defined as the change of rate of position. লেখা যেতে পারে change of position. It will be very clear. The change of rate of distance of it with time. So speed is the distance by time. Therefore speed equal to distance by time taken. Distance covered by time taken. That is S upon T. S by T. Speed is the ratio of distance covered by time taken. That is, the distance covered in unit time is called speed. The distance travelled by a moving body in unit time is called speed. Now we see what is the SI unit of speed. The SI unit of speed will be the unit of distance in SI system and the unit of time in the same system. That is, in SI system, আচ্ছা আমরা স্পিডের another definitionটা দিচ্ছি। হ্যাঁ, we give another definition of speed. That is, speed is defined as the distance covered by a moving body in unit time. That is, the speed equal to the distance, total distance covered by the body and the total time elapsed. Units of speed in various systems. In CGS system, at first we know in CGS system, then in FPS and then MKS or SI system. In CGS, that is centigram grams second, centimeter gram second system, the unit of speed is centimeter per second. We may write it as centimeter second to the power -1 centimeter per second. In SI system, in FPS system at first, in FPS system it is foot per second, that is foot second to the power -1, and in, very important, SI system, and in SI or MKS system, the unit of speed is meter per second, that is meter second to the power -1. In all systems, we see that the unit of time is second. Now we know about velocity. Write these portions. Velocity. Second topic solo velocity. The second topic is velocity. The displacement, here velocity is a vector quantity, hence we take displacement. The displacement per unit time is called the velocity of a moving body. The displacement, not displace, displacement, the displacement per unit time, the displacement per unit time is called the velocity of a moving body. We also write that the distance covered by a moving body in a particular direction in unit time is called velocity. That is the distance covered by a moving body in a particular direction. Here direction must be mentioned. In particular direction is called, in unit time obviously, is called velocity. Its unit is same as the unit of speed. Its unit is same as that of speed. That is so in CGS system that is centimeter per second in CGS system. In FPS system it is foot per second, and in SI system it is meter per second. Now, what is the difference between speed and velocity? We know that speed is a scalar quantity, but velocity is a vector quantity. Hence, speed always be positive, but velocity may be positive, negative, or zero. The speed of a body is changed if its magnitude is changed. The velocity of a body is changed if its magnitude or direction or both are changed. So, this is the main difference between speed and velocity. Now we know acceleration and retardation about motion. Acceleration. It is denoted by A. And its magnitude is denoted by only A, not arrowhead is given. Acceleration, the time rate of change of velocity is called acceleration of a moving body. Acceleration of a moving body. In another way, we give the definition of acceleration as the increase in velocity per unit time. The increase in velocity per unit time. The increase in velocity per unit time is called acceleration of a moving body. Obviously, body must be in motion. Now, so the unit of acceleration in CGS system will be centimeter per second per second. In SI system, foot per second, and in FK system or SI system, it is meter per second per second. Obviously it is a vector quantity because it has both magnitude and direction. It has both magnitude and direction. Now, we know its retardation or deceleration. retardation. At first we define them, retardation, so that you remember these physical quantities easily. Retardation. Here we write that decrease in velocity per unit time is called retardation of the body. That is that just opposite to the acceleration. Hence, if acceleration is positive, then retardation is negative. And if retardation is positive, then acceleration will be negative. For example, if a body moves along east side with acceleration, then it has a retardation in the west side, west direction. Now, retardation. The decrease in velocity per unit time is called retardation. So retardation is the negative of acceleration. Just increase, here decrease. Velocity increases in the case of acceleration and velocity decreases in the case of retardation. Retardation or deceleration. Now, we know the units of acceleration or retardation. Both are same units in all the cases. For example, in CBSE system, the unit of acceleration or retardation in CGS means centimeter gram second system. CGS system, centimeter gram second system, is centimeter per second per second. That is centimeter per second square or centimeter second to the power minus 2. Here we see that per second, that is second terms come 2 times. Why 2 times second terms? It is so because first time for the velocity and second time for the rate of increase of velocity, that is time, velocity by time. Hence 2 terms of second present in the units of acceleration or retardation. In FPS system, is foot per second square or foot second to the power minus 2. Here it is important that in centimeter no full stop sign is given, or in the case of second also, always written in this way: centimeter per second square or centimeter second to the power minus 2. Foot per second, not full stop, is given here or here. And in MKS or SI system, the unit is, the unit of them means acceleration or retardation. Acceleration and retardation. Unit of them is meter per second square or meter second to the power minus 2. Thus, unit of acceleration and retardation are same, though they are different in meaning, because acceleration, in the case of acceleration, velocity is increased, and in the case of retardation, velocity is decreased with respect to time. Now we know about uniform speed, non-uniform speed, uniform velocity, non-uniform velocity, and uniform and non-uniform acceleration or retardation. Uniform speed. If a moving body covers equal distances in equal intervals of time, whatsoever or however the small time interval however small the interval of time. Equal intervals, maybe 10 seconds, maybe 10 minutes, always 10 seconds. After 10 seconds, the velocity of the body, the distance covered by the body remains same. However small, the time intervals may be. The time intervals Now, what is the uniform speed? If a moving body covers equal distances in equal intervals of time, however small the time intervals may be. This definition is sufficient for the uniform speed. Now, we know about non-uniform speed. You may write, this is non-uniform speed, just uniform is changed into non-uniform speed. If a moving body covers unequal distances, here this is not equal, unequal distances in equal intervals of time, however small the time intervals may or may not be written. It may or may not be written in this case, in the case of non-uniform speed. Now, we know uniform velocity. Non-uniform speed, if a moving body covers equal distances in equal intervals of time, unequal distances in equal intervals of time, then this motion is called non-uniform. This speed of the body time. এটা আমরা মুছে ওই erase it. Intervals of time. Then the speed of the body of the object is said to be non-uniform. In the same way, uniform speed, if a moving body covers equal distances in equal intervals of time, however small the time intervals may be, then the velocity of the body is called uniform velocity. then the velocity of the body here, then the speed of the body is said to be uniform. In that case, the velocity of the body is said to be uniform, not non-uniform. Now, uniform velocity, uniform speed, uniform velocity. Now, uniform velocity. Uniform velocity. If a moving body covers equal distances, displacement may written displacement or distance. Distance, in the case of distance, in a particular direction must be added because it is a vector quantity. Velocity is a vector quantity. Uniform velocity. If a moving body covers equal distances equal distances in a particular direction must be added. Particular direction. If a moving body covers equal distances in a particular direction, in equal intervals of time, however small, the time intervals may be. If a moving body covers equal distances in a particular direction, must be added in a particular direction. While we write distance in a particular direction in equal intervals of time, however small the time intervals may be, then the velocity of the body is called uniform velocity. It's called uniform velocity. Or if we write, if a moving body covers equal displacements, if we don't write this, then a body covers equal displacements. No distances in a particular direction will be written. We write only the body covers equal displacements in equal intervals of time, however small the time intervals may be. Then the velocity of the body is called uniform velocity. Now we know about non-uniform velocity. If a moving body covers just unequal, not equal, unequal distances, not in a particular direction, so we write it in another, in uniform. We write it on the above, non-uniform. Not velocity, non-uniform velocity. Here, right. Here, if a moving body covers unequal, just put unequal, not equal. Unequal displacements may be put, or this may be put. distances in a particular direction or displacements in equal intervals of time. Here write only unequal. Write only unequal in this case. Here un. Put un. Unequal distances in equal intervals of time. Then this not be required to write. This not be then required to write. Just then the velocity of the body is called not uniform, that is non-uniform. We put it in a similar uniform velocity, but it is unequal intervals of time, unequal intervals of time, unequal distance displacements will occur. So non-uniform velocity will be the if a moving body covers unequal displacements in equal intervals of time, however small the time may be, write or don't write, then the velocity of the body is called non-uniform. In the case of non-uniform velocity, we are required to know about average velocity. Similarly, in the case of non-uniform speed, we know average speed. Average speed and average velocity. Average speed for a non-uniform speed of a moving body. For a non-uniform speed of a moving body, average speed for a non-uniform speed of a moving body is defined as the ratio of the total distance covered by the body by the total time taken. That is the ratio. Ratio of the total distance covered by the body to the total time taken. That is average speed equal to, we may write it as V bar or V average speed equal to what is the ratio, that is total distance, not displacement, total distance covered by total time taken. Obviously, the average speed of a moving body depends upon the time elapsed. How many times required, how many times spent for the total distance covered by the body is essential here. For example, we see that a moving body covers unequal distances, that is, its path of motion is that, a curved path. We take different points A, B, C, D, E, etc. It is a path of motion. This is the path of motion. It will be the path of motion. Here, at the point A, velocity, speed is V1. Velocity at A, speed is V1. it is tangential at the point in the curve. For velocity at B is v2 and time taken by the body to reach from some point O to A is t1, from B, A to B, time taken t2, and v3, time taken t3. Time taken velocity v4, time taken t4, velocity speed, don't velocity speed, and it time taken t5. That is, starting from O, reach at A with velocity v1 and takes time t1 to attain velocity v1 at A. Similarly, it takes time t2 to attain velocity v2 at B. It takes time t3, velocity v3 at C, and so on. So, average velocity will be equal to v1, the speed, sum of the speeds, sum of the distances, not speed, acceleration, sum of the distances. Let it is distances, so not velocity, it will be the distance covered by it from O to A in time t1, s1, s2 from A to B, s3, s4, s5, s5 from D to E, right? So, total distance, average velocity will be the total distance covered, that is s1 plus s2 plus s3 plus s4 plus s5, and total time taken, that is t1 plus t2 plus t3 plus t4 plus t5. Here total distance covered will be s1 plus s2 plus s3 plus s4 plus s5, and total time taken is t1 plus t2 plus t3 plus t4 plus t5, and hence average velocity will be this equation. If we omit the last term t5, hence s5 will be omitted also, then the average velocity will be changed. That is, average velocity solely depends upon the time taken, because the time taken is changed, then distance covered will be also changed, and the average velocity will be changed. Now, we know